Greetings to all viewers. This is Professor Ankit Singh. We'll now start with the next topic, that is design of flexible payment. Okay. So we'll discuss design of flexible payment using IRC code, that is IRC 37 2001 edition. The payment design given in the previous edition IRC 37 of 1984 were applicable to design traffic up to only 30 million standard axles. Okay, so the previous code, which was revised in 1984, was only had, or we could design road for traffic of maximum value 30 million standard axles. Okay, but now in this revised codes uh, of the code revised in 2001, we can design flexible payment up to traffic values of 150 MSA or 150 million standard axles. Okay, so this is the difference between the code that was used in 1984 up to 2001. Then there was a revision in 2001, and this is what was revised. Okay, so the design procedure. The pavement designs are given for subgrade CBR values ranging from 2% to 10% and design traffic ranging from 1 MSA to 150 MSA, where MSA is million standard axles. Okay, for an average annual pavement temperature of 35 degrees centigrade. So this is considered as a average for this is considered as a average temperature for design. Okay, average temperature of pavement. Using the following simple input parameters, appropriate designs could be chosen for the given traffic and soil strength. So first one is design traffic in terms of cumulative number of standard axles and CBR value of subgrade. Okay, so we use both these factors. Okay, and then we design the thickness of the flexible pavement. The first factor that we consider is design traffic, okay, in terms of cumulative number of standard axles, and the second factor is CBR strength of the subgrade. The method considers traffic in terms of the cumulative number of standard axles. Okay, so as we already know, standard axle load is considered to be 8160 kg, okay, to be carried by the pavement during the design life. Okay, there is some design life that we consider, some amount of years for which we design the pavement. Okay, this requires the following information. Okay, so for the design, what all information do we need? Initial traffic in terms of CVPD. CVPD stands for commercial vehicles per day. Traffic growth rate during the design life, that is the growth rate of traffic per year. Okay, we observe some growth in the traffic conditions every year. Okay, so we need to consider a particular growth rate. Then design life in number of years, vehicle damage factor VDF, and design of commercial traffic over the distribution of commercial traffic over the carriageway. We consider a factor known as lane distribution factor in this regard. Okay, so in this, the first one was initial traffic. Initial traffic is determined in terms of commercial vehicles per day. Okay, so what are the number of commercial vehicles that are using that road per day? For the structural design of the pavement, only commercial vehicles are considered, assuming laden weight of 3 tons or more, and their axle loading will be considered. Okay, so for the design, for the structural design of the flexible pavement, only the commercial vehicles are to be considered. Estimate of the initial daily traffic flow for any road should normally be based on 7-day 24-hour classified counts. Okay, So the traffic data that we get should be obtained after survey. Okay, and that survey is conducted for 7 days and it is conducted for 24 hours. Okay, so in each day 24-hour data and total conducted for 7 days. That traffic data we need to obtain, and that is known as the ADT. Okay, in case of new roads, traffic estimates can be made on the basis of potential land use and traffic on existing routes in the area. Okay, so if we are planning for a new road, if there is a no existing road there, then we cannot carry out a traffic survey. Hence we need to decide the traffic volume based on the potential land use of that area, and also we can compare similar existing roads, okay, in and around that area. Then we have traffic growth rate, as I already discussed. Okay, traffic growth rates can be estimated. We need to estimate this part using statistics by studying the past trends of traffic growth. Okay, so we can study in the previous year to the upcoming next year what was the growth in traffic. Okay, similarly we can obtain a chart of previous years and their growth rates. Okay, by establishing econometric models, or we can model the growth rate. If adequate data is not available, it is recommended that an average annual growth rate of 7.5% may be adopted. Okay, if we cannot obtain the growth rate, then we have a standard value that is given by IRC, that is 7.5%. Then we have design life. For the purpose of pavement design, the design life is defined in terms of the cumulative number of standard axles that can be carried before strengthening of the pavement is necessary. It is recommended that pavements for arterial roads like NH and SH should be designed for 15 years, that is National Highway and State Highway, EH and urban roads for 20 years, that is express highways and urban roads for 20 years, and other category of roads which could be MDR, ODR and VRs, they could be designed for 10 to 15 years. Then we have vehicle damage factor. This I have already discussed in my previous classes. We'll just have a look into it. The vehicle damage factor, or VDF, is a multiplier for converting the number of commercial vehicles of different axle loads and axle configurations to the number of standard axle load repetitions. Okay, so we are converting vehicles with different axle loads and different axle configurations into a standard axle load. Okay, that is nothing using a factor which is nothing but vehicle damage factor. It is defined as equivalent number of standard axles per commercial vehicle. The VDF varies with the axle configuration, axle loading, terrain, type of road from region to region. Okay, so this VDF will depend upon all these conditions. The axle load equivalency factors are used to convert different axle load repetitions into equivalent standard axle load repetition. Okay, we have already gone through this. For these equivalency factors, we can refer IRC 37 2001. Okay, in this code, standard values have been mentioned based on traffic. Okay, for different traffic values, different VDF values have been mentioned. Okay, we could either do this or we could also estimate the VDF values. Okay, using a formula. Okay, that formula I've already discussed in my previous classes. That is the given axle load, that is P, divided by standard axle load, that is 8170, whole raised to 4. Okay, we could use that formula and find out VDF, or we could use the standard values that have been provided in IRC 37. Okay, then we have lane distribution factor. LDF, or lane distribution factor, is a decimal fraction which indicates the concentration of placement of wheel load repetitions along a road. Okay, I'll explain this. Let me read it out first. Multi-lane undivided one-way pavement. Driver has a tendency to place or position his vehicle towards the center or away from the edge. Near the edges, lower concentration of vehicle load repetition is observed. For this reason, based on the number of traffic lanes, only a part of the commercial traffic volume is taken as design traffic volume on the economic consideration. Okay, so lane distribution factors tells us about the percentage of road that is being used by the drivers. Okay, because the drivers tend to travel at the center of the road and do not use the edges. Okay, so what we try to do is we try to estimate only the part of road that is being used by the drivers. For that we have a factor, that is lane distribution factor. Now we have standard values as per IRC for lane distribution factor. For single lane roads, total number of commercial vehicles in both directions, that is we are taking 100%. Okay, there is no reduction for single lane roads. For two lane single carriageway roads, 75% of the total number of commercial vehicles in both directions. Now there is a reduction here, we are taking 75%. For four lane single carriageway roads, 40% of the total number of commercial vehicles in both directions. So for four lane single carriageway, 40%. Then for dual carriageway roads, 75% of number of commercial vehicles in each direction. And for dual 3-lane carriageway and dual 4-lane carriageway, distribution factor will be 60% and 45% respectively. Okay, so these are the standards which have been given in IRC 37 and we can make use of these when we are designing the roads. Then we have the traffic data which we need to estimate. So initial data in terms of number of commercial vehicles per day, that is CVPD, we need to find this out. Then traffic growth rate during design life in percentage, design life in number of years, distribution of commercial vehicles over the carriageway. These are the values that we need to obtain before we can design our flexible pavement. Now, computation of traffic for use of pavement thickness design chart. Okay, firstly, how do we compute the traffic? We have a formula here. Okay, we have a formula to find out capital N, that is cumulative number of standard axles to be catered for the design in terms of MSA. MSA is million standard axles. Okay, so we use this formula to find out capital N. The formula is 365 into A into 1 plus R raised to N minus 1 bracket closed into LDF into VDF whole divided by R. Okay, where LDF is lane distribution factor, VDF is vehicle damage factor. A is initial traffic in the year of completion of construction in terms of number of commercial vehicles per day. Okay, now this A value may be given in the question, or if it is not given in the question, then we have another formula to find out the A value. Okay, I'll discuss that later on. Then we have N. The small n is nothing but the design life in years. Then R, it is the annual growth rate of commercial vehicles. Now, if in the question we have not been given the initial traffic, that is A, then we have a formula. A is equal to P into 1 plus R whole raised to X. Now, where P is the number of commercial vehicles as per the last count. Okay, whenever the last count was done, last traffic count was done, the total number of vehicles using the road, that count we can use here in order to find out the initial traffic count at this year. Okay, at this design year. Then what is X over here? It is the number of years, sorry, this is years. Okay, YEARS, between the last count and the year of completion, between the last count and the year of completion of the project. Okay, so this is that X is nothing but the construction period, you can say construction period of that road. then R, annual growth rate of commercial vehicles. It is the same. Okay, so this is the formula we use in order to find out the cumulative number of standard axles to be catered for design. Now where do we use this value? We have these charts that have been given in IRC 37 2001. Okay, from these charts you can directly find out the total thickness of the pavement, since the CBR value will be given in the question itself, okay, while you design. Okay, so you have capital N values along the x-axis, total thickness of pavement along the y-axis, and you have these graphs that indicate CBR values. Okay, so I'll discuss this in detail when I solve a design problem. Okay, so what happens here is, with the help of the CBR values and with the help of the design traffic, we can project okay, assuming we have design traffic of 5 MSA over here. Okay, and the CBR of our subgrade is 10%, that is this last curve. Then we can project a horizontal from 5, it will cut this curve at this point. Then we can project a horizontal from here, sorry, we project a vertical from here, then we project a horizontal from here, then we get a point over here. Okay, we can get some value, assume it is something around 420. Okay, so this is nothing but the total thickness of the pavement, 420 mm. Okay, so this is how it's done. Then later on we also have these tables. Okay, so we go to the table for CBR 10. Okay, all these tables are given in the IRC code. Okay, then you go to the table for your specific design CBR, then you have a look at your thickness. Okay, whatever thickness you have obtained, then you can decide the thickness of the different layers which are being used in your road. Okay, what would be the thickness of wearing course, what would be thickness of binder course, base and sub base. Okay, so this is how you design using IRC 37. Okay, so the next topic is rigid pavement design. I'll start with this in my next class. Thank you.